Okay, hello everyone. Okay, this video I'm going to show you the calculation on the bending stress calculation in beam. Okay, yeah, bending stress calculation in beam. Yeah, it's also kind of okay. Take some time. So I think you really need some demonstrations. And here's the problem from the textbook 11.12. Okay, he said there's a beam, fixed beam here. Okay, and then we apply an external loading on this beam. And you want to calculate, okay, determine the maximum bending stress that occur in the B section at 8A. Okay, section 8A is here. Okay, when it comes to calculation the bending stress in beam, okay, so do you remember the okay, do you remember the formula for the calculation, the formula bending stress in beam? Okay, let me write this for you. Okay, the bending stress in beam, I think previous slide has shown as minus my over I. Okay, and m is the moment, and y is the point of the point of interest, the distance between the point of interest and the neutral axis. Okay, and I is the moment of inertia of the cross section area. Okay, so he say you want to determine the maximum bending stress that occur in the beam at section AA. So first of all, you want to determine bending stress. So you need to know the moment of this cross section AA. Okay, you need to know the moment of this cross section AA, and you want to determine the max bending stress. I think you need to max y. Okay, you need the y max, and the y max. So you have to understand the max distance between the max distance is on the surface. Okay, so this is a beam, so there's a cross section area of this beam. Okay, the y max, I think that's maybe the top or the bottom. Okay, max, because there's a distance between the point of interest and the neutral axis, so it's maybe on the above the neutral axis or below the neutral axis. Okay, and you want to maximum, that means it's top or the bottom. Okay, and I the moment of inertia. So no matter what, so in this problem, because you need to determine the distance between the neutral axis and the maximum point of y, and also you need to determine the moment of inertia. So in the very beginning, you need to determine. So you have to calculate the neutral axis at the very beginning of this problem. Okay, because if you don't know the neutral axis of this cross section area, you cannot calculate the y or the moment of inertia. Okay, or the moment of inertia cross section area. Okay, so and here he give you the information of the cross section area. Um, yeah, I think this picture it already give you the answer of it. Okay, it already give you the answer. Okay, it said the y bar is here, but it's given. But I want you to learn how to calculate the neutral axis. Okay, so the neutral axis. Okay, let's draw the shape of this cross section area. Okay, how to determine a neutral axis? So it's very similar to the calculator centroid of composite area. Okay, so let's say this is ground zero. This may be too long. We set this is ground zero. Okay, and he give us a dimension. He said the dimension, the cross section area, the dimension is say here symmetry. He say here is 15, and here is 250. Okay, but it's a unit millimeter. Be careful. And what else? He say here is 20 and it's symmetry. Okay, left and right symmetry. Okay, where is the neutral axis? So okay, the problem you cut this, you cut in this fashion, but I want to choose another fashion, cutting fashion. So I cut this fashion here. Okay, I cut the fashion here. I cut in this fashion. So I have area. I have area one, area two, and area three. Okay, if you're dealing with composite area, okay, divided your complicated shape into a simple shape. And the next one, determine the centroid of each area. Okay, the centroid might be here, the centroid is here, and the centroid is here. Okay, so okay, let's calculate. Okay, what is A1, A2? Okay, the Y bar. Okay, the Y bar is here. In this problem, we have three area. So it's A1, A2, A3. So it's A1, Y1 plus A2, Y2 plus A3, Y3. So what's our A1 and A2? Okay, A1, A2 actually they are the same. Okay, so A1, okay, the here is 50 millimeter. Okay, and times the height here. Okay, oh, I missed the one of the information. The total height here is the total height is 50. Oh, sorry, is 200 millimeter. Okay, so the height of area one is 20 minus 200 minus 20, so it's 180. Okay, hopefully you can understand. So it's 180 millimeter. Okay, so that's the area one, area two. So you multiply these two. So what's your answer? 7 times 180, 2,700 10 to the power minus 6, and its area, so it's m square. Okay. Okay. The next one is where is the what is A3? Okay, where should I put A3? Okay, I put A3 here. Okay, A3 here is 20. Okay, 20 millimeter. Okay, and times this here is 250. He is 15, so he is 15. So it's totally is 280. Okay, 280 millimeter. Okay, so what's the answer? Okay, so it's 5,600 10 times 10 to the power minus 6 m square. Okay, so with this information, we can add this. Oh, sorry, we haven't. We need y1, y2, and y3. So I put the y1. Okay, I put y1 here. Actually, y1 is equal to y2. Okay, y1 is here. This centroid is here. So centroid here is, so you see here this is 200. But sorry, here's 20. So this must be 180. So here is 90. So y1 and y2 is equal to 90 millimeter. Okay, so and what's the y3? Okay, y3. Okay, centroid is here. Okay, area 3 centroid is here. So here is 10. Here is 10. So it's 180 plus 10. So it's 190 times 10 to the power minus 3 m. Okay, so with this information, we added together. So A1 plus A2 plus A3. So you will see it's a 40. This will be 5400 plus 5600. Okay, so what's the number? So it's a 11000 times 10 to the power minus 6. Okay, so that's our denominator. So our numerator is, so A1 is 7% times 10 to the minus 6, and times this is 90 times 10 to the power minus 3. It's really take a very long, it's a long equation. A2 times Y2. I don't have any space here, so where should I put a number? Okay. Okay, maybe I write it here. Maybe I write it here. Okay, A1 is 27. A1 y1 plus a2 y2, and the final one is a3 y3 is 190 times 10 to the power minus 3. Okay, so and then we add them together, so it's okay. We deal with the 10 to the power minus 9. Okay, and okay, so let's add this together. 277 times 90. 2700 times 90 times 2 and plus it's 5600 times 190. Okay, so it will be 1550000 okay, so you can divide it here, so okay, 1550 divided by 11, so it's 140.9. It's 140.9. Is this correct? 140.9. Okay. Okay, so it's one. So the final answer, y bar is 140.91. Okay, and then it's 10 times to 10 to the power minus 3 and meter. So it's 140.91 millimeter. So that means the centroid, I think the centroid, sorry, that's not centroid, it's neutral axis is here. Neutral axis is here. So it's our neutral axis, and its height is 140.91 millimeter. Okay, we find our neutral axis. Okay, so we finished with very first calculation, but I don't have any space right now. So right now I have to erase something on this screen. So if you want to take a note, please rewind. Okay, we finished the calculation. We find where the neutral axis is 140.91 millimeter above the basis. Okay, above the basis. Okay, so okay, so I have to erase everything here. So I keep the area. Okay, I keep the area, and yeah, and y1, y2, y3. Okay, so I think we can erase. I keep the area. Okay, so we find out our neutral axis. Okay, when we find out our neutral axis, the next thing is okay. We just we calculate the moment of inertia of this cross section area directly. Okay, because once we have neutral axis, the next thing we calculate moment of inertia. Okay, and calculate moment of inertia of this cross section is the same thing. We still use this three cut sliced area. I equal to I1 plus I2 plus I3, and I1 actually is equal to I2. So okay, so for the neutral axis, you have to understand the neutral axis is not passing through the area, the centroid of area 1 or centroid of area 2 or and even the centroid of area 3. So so neutral axis is not passing through the centroid of each area. So when you want to calculate the moment of inertia of this cross-section area, you need to use a parallel axis theorem to calculate moment of inertia. So that means you have to use the formula for the calculation of the moment of inertia around the centroidal axis and plus AD squared. Okay, so that's so 1 over 12 BH cubed. Okay, because right now the neutral axis is a horizontal one. So here is your B, and here is your H. Sorry. 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 H. Here is your H. No. Oh, no, 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 no. Okay. So, okay, H is this one is your H. Okay, here is your H. Okay, so B is 50 millimeter. Okay, and times the H cubic. H is 180 cubic. Cubic. Okay, so let's do the calculation on this. Okay, it's 15 times 180. Oh, sorry. 15. Uh, 15 times 180 then one. Sorry, it's 15 times 180 times 180 times 180. Okay, and then 10 to the power 2. Sure. Okay, divided by 12. Okay, so here is 7.29 times 10 to the power minus 6, and I think it's m power 4. Okay. Okay, so that's is I1 and I2. So what was the I3? Okay, it's the same. Sorry. Ah, this is not good. I I oh. This is not good. I I forgot to add the AD square. Yeah. Oh, yeah, it's very easy to AD square, A and D square. Okay, so A area is 50 millimeter, 50 millimeter times 150 millimeter times 180 millimeter. And D square, D is the distance between the centroid and the neutral axis. Okay, so what's the distance between the this centroid and neutral axis? So here is 180. So here is 90. Be careful. So here is 90. So the neutral axis is here and here is 90. So distance of centroid of area 1 to the neutral axis is 50.91. So it's 50.91 10 to the power minus 3 square AD square. Okay, that's our that's our answer for 15. Oh, it's very horrible calculation. It's very horrible. How it take a very long time to finish this calculation. So okay, that's AD squared. So 15 times 180 times 10 to the power minus 6. Okay, times 43.91 times 50.91. Okay, times 10 to the power minus 6. Okay, and plus say, okay, it's just 6.997 times 10 to the power minus 6. Okay, so what's the answer? So 7.29 10 to the power minus 6. Okay, so it's 1.429 10 to the power minus 5. Oh, okay, it's M4. That's the M4. Me4. Okay, so that's I1 and I2. Okay, so next thing when I'm finished, what is for I3? So I3 will get 1 over 12 and BH cubic. B is now is here. Here is your B. Okay, because right now it's horizontal. Neutral axis is horizontal. Here is your B. B is 250 millimeter plus 15 and plus 15. So it's 280 millimeter. And B H cubic, and H is here, H is 20, so it's 20 cubic millimeter. Okay, 20 millimeter cubic, and plus AD square. So AD square, what's area? It's 280 10 to the power minus 3, and 20 times 10 to the power minus 3, and the D square. D is the distance between the centroid of area 3 to the neutral axis. And we already know Be careful. What's the distance? Okay, so it's 10 here. It's 10 here, and we need to know where is central neutral axis here. So what's the value here? What's the value here? Let's see. So here is 100 and 180 is here, and minus 140.91, and 180 minus 140.91, and plus 10. Plus 10. Yeah, we need a plus 10. Yeah, plus 10. So it's 49.09 10 to the power minus 3 square. Okay, so what's our I3? I hope my calculation is correct. Yes, really horrible. Wait, times 20 times 20 times 20 times 10 to the power minus is 12 divided by 12. And so the first one is 1.8667 10 to the power minus 7. It's not huge. AD squared 280 times 20. Okay, 80 times 20 times 49.09 times 49.09, and 10 to the power minus 12. Oh, so it's 1.3495 10 to the power minus 5. Okay. Okay, and it's plus 1.867 times. Let me find 7. So it's 1.3682 times 10 to the power minus 5. Okay, so what's our I? Okay, it's 2 times I1 plus I3. So what's the answer? Let's see. 2 times 1.429 plus 1.3682. Okay, 4.2261, 4.2261 10 to the power minus 5 and 4 power 4. Okay, so I'm not sure my calculation. 2261, 2256. My answer. I hope my calculation is correct. Okay, I think because of my notes, I cut the area in different. I cut the same fashion as the textbook, but in this example, I cut in different fashion. But we will have you no matter what cut fashion you will have the same answer. Okay, so my answer. Actually, my notes answer is 4.2256. So I think maybe I did the right calculation. Okay, so here we finish the moment of inertial calculation. Okay, and we already determine neutral axis and moment of inertial calculation. And the final one, we need to determine what's the moment of this section AA. Okay, so we haven't finished this calculation yet, so let me erase this area. So if you want to take this note, please rewind. Yeah, and it's going to be very long calculation. Yeah, I think you haven't experience on this. Actually, this is the feature for the engineering calculation. I won't say it's difficult, but it really takes lots of time to calculate the answer. It really takes lots of time, and you need to use lots of formula to calculate the answers. That's the feature for engineering calculation. No matter what kind of engineering you're studying, Engineering calculation that's the feature of engineering calculation. Okay, so the final thing is we need to know what's the moment of this cross section area, section AA. So how to calculate the moment of section AA? Yeah, okay, so don't forget. Okay, if cut section method. Okay, section AA is here. A is here. And we apply external loading here, 2.6 kilonewton. Okay. Okay, so do you know how to compute, how calculate the moment of this cross section area, internal moment? Do you know the internal moment calculation? Yeah, don't forget. Yeah, in the first half of the semester, we calculate. Okay, we can assume there's a shear force here and normal force here, and also we also have the internal moment here, right? How to find the internal moment and the moment out here? Okay, use the rigid body equilibrium, right? Okay, don't forget it. Okay, so how to calculate the moment here? Okay, so also let's see. Okay, so first of all, with 2D problem, first of all, we decompose this external force. Okay, this has decomposed in these two. So it's 13. This will be 2.4 here, and this will be 1 or 13 0.2. Oh, sorry. It's wrong. Okay, 0.2, 0.2. So this is here's 1. Here's 1 kilonewton, and here is I think it's 2.4, right? 2.4. Okay, let me check the answer. 1, 2.4. Yeah, okay. And he's acting here. He's acting here. The force is acting at here. And the cross section A, and here is 2 meter. Okay, so what's the reaction moment? Okay, so we choose the A section A as the reference point. Okay, so I mentioned the total moment of it's the whole system in rigid body equilibrium. So is 0. Okay, so M we don't know. And this force will create a moment. Okay, this force will create a moment with respect to A. So and it's the reference point is here. So it's 2.4 times 2, 2.4 times 2, and it's counterclockwise. So it's positive. And does this force create a moment with respect to the AA section? Uh, Actually, yeah, this force based on this cross section area. This force will create a tiny moment with respect to with respect to the AA section. Okay, because you see, it's you have to write. We have to write because the cross section area is here, so there is a so, and the distance here is the distance here is so it choose it's 1. Oh, maybe you can it's 1 times. Oh, cool. Yeah, I have confused here. Let me see. It's confused. MAA times 2 times 59.1. Okay, so it say you need to calculate the moment with respect to the neutral axis. Okay, so this force is very small, but it will create a moment with respect to the neutral axis. So this force, what is this distance? Okay, we already calculate this force here is 140. Here is 140, 114.91. Okay, so that's why the picture here it shows you, okay, the surface of this beam, the distance between the surface of this beam to the neutral axis is 59.09 millimeter. Okay, and this distance, you have to use this distance to calculate the moment. This distance to times the force here, and this also create a counterclockwise moment. A counterclockwise moment, 1 times 59.09 and equal to 0. Okay, so right now, sorry, so this is the distance here we use is unit is this is a meter, so we have times 10 to the power minus 3. So you will see this really a very small value. I really don't know why the textbook want you includes in this moment. You see, I think the answer is very very close to minus very close to minus 4.8. Okay, minus 4.8. Mm-hmm. Okay, very close to 5.8. Okay, if you don't consider this value, it's minus 4.8. If you consider this, the value is just 4 minus 4.8 and 5.9. Okay, and the unit is kilonewton times m, and it's kilonewton times m. You see that actually is very minute difference. Yeah, I really don't know why this textbook always want to calculate this. I really don't know. I really don't know. I re Actually, in my opinion, you don't. I think you don't even you don't even have to consider this. Okay, so anyway, we have our moment. Okay, so we just choose the textbook value. Okay, so what's our you want us to calculate the maximum bending stress, okay, in beam. So max. Okay, so we have minus here. Let me see. Okay, so it's minus 4.5 859. And the moment of inertia is moment of, yeah, was okay, so 4.2261 times 10 to the power minus 5. So it's kilonewton. Okay, so we have to times the 10 to the power 3. 2 times, yeah, 10 to the power 3. Okay. Okay, the next one is y. Okay, so if we want to have the maximum value. So the only thing we left is, can we have the maximum of y? Okay, what's the y maximum? Y maximum. So as I say, the maximum is it's just only you only have two choices. One is top of the cross section area, and then below of the sorry, top the top of the cross section area and the bottom of the cross section area. And we see, okay, if we top of cross section area, what's the distance of the top surface to the neutral axis? So right here is yeah, that's here. So it's 59.9 millimeter. Okay, it's top surface. Okay, if your y bar, your top is 59.09 millimeter. Okay, yeah, because here is 50 millimeter, right? Yeah, 59.09 millimeter. And we have another choice. What's about the bottom? What about the bottom? Bottom is here. Okay, so bottom is here. It's 140 and 91. 140 and 0.91 millimeter. Yeah, if we want to have a maximum bending stress, it looks like, because this has greater value and it's below the neutral axis, so it looks like we have to times minus 140.91 times 10 to the power minus 3. Okay, why is it negative? Because it's below neutral axis, And the top, yeah, because this has great value than white top. So this value will give you the maximum shear stress. Okay, let's look at this answer. Okay, let's look at this answer. Oh my God. Oh my God. Okay, let's move. Finally, we finish this calculation. 4.859 times 140.91 divided by 4.2261. Okay, and the final answer is 2.01 times, because it's 10 to the power 5. Okay, so it's about 16.2 megapascal. Okay. Okay. Okay, we finish the calculation of this problem. The maximum shear stress of this cross-section area is 16.2 megapa. Okay. Okay, see this problem? How many time we spend on this problem? I think 40 minutes. Yeah, maybe 40 minutes. Okay, it's our video here. Okay, see you next time. Hope you enjoy this calculation. Yeah, there is no other way, simple way to calculate this problem. Okay, see you in next time. Bye bye. Oh.